Hey, everybody. Thanks for joining. Uh, in this talk, we're going to talk about becoming a secret agent, securing your GraphQL backend with JWTs. So this talk was inspired by an article that Asura put out about a year ago, almost a year ago to the day. This article was about securing your front end with JWTs, and it sparked a lot of conversation and a lot of confusion and a lot of questions about then how you would use JWTs on the back end. So that's why I wrote this talk. And the truth is that auth in GraphQL, authorization and authentication, can be really confusing. We're used to doing things in REST where we maybe have this endpoint and we know we need to secure it. So we go ahead and just kind of slap a middleware onto it where we authenticate and then we send the user a response. And this is sort of a familiar process to us. But when we start building a GraphQL backend, we kind of run into this issue where we have one endpoint instead of multiple endpoints, just this /GraphQL. So what do we do there? Do we just put middleware blocking the entire endpoint? Do we need to add authentication to our resolvers? It can be a really confusing scenario. And that's what this talk is all about. So I'm Sam Julien. I am a developer advocate for Auth0. We're an identity as a service platform. Basically, we handle your authentication and authorization so you can focus on building the features of your application. I'm also an Angular and web Google developer expert and part of a collaborators program with the Angular team. I also love to teach. I love to teach through video. So I've made videos for Thinkster and Egghead, and also have an NG upgrade course that I've made. So in this talk, all of my examples are going to be in JavaScript, usually using Apollo, but the concepts aren't really specific to JavaScript. You'll see JavaScript syntax, but this should be applicable to whatever backend language you're using. Okay, so in this talk, what we're going to do is first we're going to have some auth background. We're going to talk about some concepts of auth, and then we're going to get into JWTs. What are they? Why do we use them? And then once we cover that, we're going to focus on authorization in GraphQL. So let's jump right in. First, let's cover some auth background. I used the terms casually earlier, authentication and authorization, but what do those terms actually mean? So authentication is basically, are you who you say you are? Basically proving your identity. On the other hand, authorization is concerned with, do you have permission to access certain resources? So authentication, are you who you say you are? Authorization, do you have permission to access what you're trying to get to? So if we look at our user in relation to GraphQL, the user is interacting with our GraphQL server, maybe through a client of some kind, a front-end client. And then the GraphQL server is interacting with our database. So if you think about this, the GraphQL server is really just this intermediary layer between the user and the database. And because of this, the GraphQL server doesn't necessarily care about the user proving who they are. It actually just cares about who has access to what. So instead of the GraphQL server caring about authentication, it's mostly concerned with authorization. And we use this word access. And this is sort of the crux of the problem when it comes to GraphQL and authorization. So let's look at a common scenario that happens. Let's say we have a backend and a front end on the same server. So we have, for example, maybe a GraphQL server and then a Next.js front end. What happens is that the user will go ahead and send their credentials to the browser, and then the browser will pass that back to the server, and then the server will use those credentials to create a cookie that then gets sent back to the browser. And that's how we keep track of a session. And for this simple scenario of just a backend and a front end on the same server, this is perfectly valid, perfectly viable way to do this. But when we start getting beyond this kind of simple example, things get a little bit more complicated. Oftentimes in the real world, we end up having a scenario more like this, where we have a single front end that then is calling multiple backends, maybe our GraphQL server and then several other APIs in the cloud. Another really common scenario is to use an API gateway. So the front end is calling an API gateway, and then that API gateway is going out and getting data from various APIs around the internet. And so here what we have is a little bit more complicated scenario regarding access. Because instead of just needing access to resources that are on the same server as the front end, what we have is this problem called delegated access, where we need access not only to something on the same server as the front end, but access to multiple third-party servers and APIs. So instead of being able to do something like this, where we can just pass our credentials and get a cookie, we need another artifact, something that's going to help us in this scenario where we have multiple APIs or maybe an API gateway. The thing is that cookies don't really work in these scenarios. Cookies are really not meant for these kind of third-party scenarios. You may have heard of CORS errors, cross-origin errors, and this is sort of one of the reasons why cookies aren't a great fit for this scenario. But if we can't use cookies, what is it that we need? We need something that can contain useful information, something like the claims that the user might have about this data. And we also need this thing to be able to be signed and verified. We need to be able to prove that the little artifact that we have came from where we expect it to and is the right thing. We can't just let just anybody send this artifact over and just blindly trust it. So what is this thing, and how do we safely create it? Well, this artifact is called a token. And a token is what we're going to use to store this information and send it to our servers. We create the token with an authorization server. The authorization server is what helps us make these access control decisions in your app or API. So this authorization server is going to create something called an access token. It's going to be a little token that informs the API that whoever has the token has the permission to access what they're trying to access. And here's how this is going to look. We're going to have this server, this authorization server, and it's going to create this access token. It's going to send it over to the front end, and then the front end is going to attach that token to the request that goes to our server. And this might be our GraphQL server. This also works in the scenario of the API gateway. This also works in the scenario where we have multiple servers as well as an API gateway. So an access token. What is an access token? You've probably actually seen an access token before. You've probably seen this on a header, this authorization header, and then there's this bearer word, and then there's just sort of this string of things that comes after the bearer, and that's what the actual token is. So we mentioned that this needs to be able to contain useful information and also can be signed and verified. So there's a format for this that's actually very convenient, and it's called a JSON Web Token. Now, this is a really commonly used format for an access token. It's not actually required, it's not mandatory to use a JSON Web Token, but it is a convenient format for it. And JSON Web Tokens look like this. And at first glance, this can look like just kind of a bunch of garbage, right? We don't know what's going on here. But if we break it down, it's a little bit easier to understand. What's happening here is actually that a JSON object is being run through a encoding algorithm, and then it gets spit out as this string of letters and numbers. It's called base64 encoding. And a JSON Web Token actually has 3 parts that look like this, and they're separated by periods. So the first part is called the header, and this is the algorithm and the token type. The second part, after the first period, is the payload. This is where all kind of the good stuff is. And there are some things that can be included in here and some that cannot. The one that I really want to draw your attention to is this subclaim. It's kind of like the equivalent of a user ID, and that'll come back a little bit later. The last part is known as the signature, and this is what lets us know for sure that it came from the authorization server that we expect. So now we have something that can both contain useful information and can also be signed and verified. An example of this is in Asura. If you've ever used Asura, if you want to include claims in your token, you add this little namespace that says asura.io/JWT/claims, and you can add things like the roles that you expect this user to have. And then when you send it over to your server, you can just pull off those claims from the token. So what happens is the authorization server sends over this token to the front end, and then it sends it over to our GraphQL server. And so now we've got our layer between the GraphQL server and the database, or between the user and the database for our GraphQL server. And now we need to do some sort of work with that token. And remember, we said that the GraphQL server isn't necessarily concerned with proving the identity with the authentication part, but it is concerned with the access management, basically. So the authentication piece will probably live outside of your GraphQL server. It'll either be through some third-party service or you'll make it yourself, which begs the question, should you just build your own authorization server? That's a reasonable thing to do. You totally can. The thing is that you want to be sure that if you are going to build your own authorization server, you need to remember how to implement proper password controls and make sure that you're transmitting your password securely. It's a lot of stuff to prevent, a lot of security considerations to take into place. So I do want to recommend that if you have a large, complex application, that you consider outsourcing this piece of your app. Now, I know what you're thinking. You're thinking like, yeah, this guy works for Auth0. Obviously, he's going to say that. But bear with me. It doesn't really matter if you use Auth0 or not. You should still consider using one of these types of services just because of the sheer volume of security considerations to take into place. Okay, so we've got the scenario where we've got multiple APIs, we've got an API gateway or something, and we're using an access token. Now we need to actually do something with it. And that's what we're going to talk about with authorization in GraphQL. So what happens is we get this request, and on that request to the server, we've got this authorization header, and it's got our token on it. So now we need to do something. We need to verify the token, and then get the payload off of it and do whatever we need to do with it. So we'll get the token, and then we'll parse the claims for authorization. So how do we do that? Well, the first thing we need to do is just actually grab the token off of the request and put it in our context. So what we can do is in our, this is the constructor for Apollo, we have our context function, and inside of here, we can just look for that authorization header and pull off the token and return it in our context. But we can't just blindly pull it off and then send it on our way. We actually need to verify that it's a valid token and then pull off the payload from it. So how do we do that? Well, we're going to make this function called verify token, and it's going to take in the token that is on the header, and it's going to return the payload to us. So remember, we've got this bearer word in front of the token, so we need to actually pull off, separate those two out. We can just do that with a string split, pull it out, and grab just the token. We don't need the bearer word. And that last part of the token is the signature, and this is what we need to verify. So to do that, there's actually a format called the JSON Web Keyset format. And what this is a kind of public and private key encryption. So we can go to our authorization server and say, hey, I've got this token. I need to know that you are the one that actually signed this key. So what we'll do is we'll add some information from our server for this endpoint that stores the public key. And then we can use like a library, a JSON Web Keyset library, go get that public key off of that endpoint, and then pass it on to the rest of our function. We'll use some sort of JWT library and verify it by passing in the token, the public key, and then some information about our authorization server. Once we do that, we're either going to get back the payload or we're going to get an error. So we're going to wrap that in a try catch, and we're going to get a look for the payload. If we get the payload, we'll return it. If not, we'll go ahead and throw an error. So now we have our verify token function that takes in the token and returns our payload. So the question is, where do we actually do this? Do we do this inside of our resolvers? Well, we could. It's just that if you think about it, we'd end up doing that a lot. Basically, anytime we had a protected resolver, we would need to duplicate this functionality. And so that doesn't feel right. That doesn't feel very efficient. It's better if we do this in our context. So let's take a look at what that is. So in our context, when we create our server, we can actually create this create context function. And inside of it, we can initialize two variables, a token variable and a current user variable. And we're going to go ahead and initialize them to null and return them no matter what. The reason we want to do that is sometimes we're going to have public-facing resolvers, right? We're not always going to protect every single resolver. You might, but if in the case that you have a mix of public and private, you're not going to want to error just because the user doesn't send a token along with the request. So we're going to do some try catch, and we're going to do this where we go ahead and initialize some null values. So first we need to see if there is a token attached to that request. We're going to go grab the token off, and we're going to call our verify token function. If we have a token, we'll call that verify token function. And then what's neat is that because we're going to get the subclaim off the payload, which is basically the user ID, we could then go and query our database for the user that is making the request. And then we can add that to our context. So if we don't have a token, or if it's not actually not if we don't have a token at all, but if we have an invalid token, maybe it's expired, maybe it's been hacked some way, we can just throw an error and say that we're unable to authenticate. And then we'll just go along, and now we have both the token and the user in our context. So we'll just use that create context function when we're building out our server, and we can pass in the request to that create context function. And so now when we go into our resolvers, let's say here we've got this create event resolver, and inside of there we've got our parent, our arguments, our context, and our info. We can actually check and say, hey, if I have a user, then that means I'm authenticated. If not, I can go ahead and throw an error because I want this user to be authenticated before I let them create a new event in the database. So if we do have a user, we can pull it off of the context, and then we can check to see if they have the right permissions and proceed to create the event in the database. So this is one way of doing it. There's a few different ways that we can make this a little bit more elegant. And one of them is by composing resolvers together instead of having to do that manual check every single time. So here's what this looks like. Basically, we can pull out this isAuthenticated function as a higher order function, where we are going to pass this function the next resolver. So we have our isAuthenticated, we're going to return the next resolver. If we're not authenticated, meaning we don't have a current user, we're just going to throw an error. Otherwise, we'll move on to the next resolver that the function is wrapped with. Here's what that looks like. We have our isAuthenticated, so this is our create event resolver again. And we've got our isAuthenticated higher order function that's wrapping the rest of the resolver. So we can check for it, and if all goes well, then we're going to have the current user in our context. Remember, we were throwing an error in the isAuthenticated function, so we won't reach this point if we're not authenticated. Otherwise, we can go ahead and check the permissions and create the event in the database. We could also go one step further and pull out the check permission function, and then do the same thing, basically. So we're passing in the next resolver, and we're going to check for those permissions and then move along if we don't have them. And so now the kind of double wrapped create event resolver looks like this, where we have isAuthenticated, which is wrapping check permissions, which then wraps the call to the database. So this is one way of doing it. It's a little bit complicated, a little bit hard to read. And so the community, the JavaScript GraphQL community, has come up with some other ways that we can accomplish this. There's a library by Lucas Constantino called GraphQL Resolvers that lets you do this. It adds kind of a layer of abstraction that makes this a little bit easier to understand. So we have our isAuthenticated, and then what's nice is we can just basically check if we have a user, and if not, the GraphQL Resolvers library provides this skip function that basically just means like, don't do anything and move to the next thing in the sequence. So here's how this looks with this library. What's nice is we have this combine resolvers function that this library provides us, and so then we can chain together, compose together the the other functionality that we need. So we have is authenticated, followed by check permissions, followed by the creation in the database. There's another library called GraphQL Modules that's a slightly different approach to this, where we can compose together resolvers. So we have this resolvers composition object, which gives us an array, and inside of that, we have our is authenticated and our check permissions, and we can kind of chain them together. So basically, this library is saying, hey, when you encounter the create event mutation, first tack on these other two resolvers that we've created for checking authentication and permissions. Another approach, which is a little bit different than this, is using a middleware approach. And there's a library by Prisma called GraphQL Middleware that makes this a lot easier than writing it ourselves. So for example, we could basically create a auth middleware object. It's kind of like a key value map almost of saying like, hey, when you come to create event, I want you to run this is authenticated function before you run the create event mutation. And then we just kind of pass in all of these different middleware objects into an array, and when we construct the server, that gets put into place. In fact, there's actually an entire library based around this approach for specifically auth and permissions, and it's called GraphQL Shield, so you can check that out. The last approach that we're going to look at for authorization is custom directives. So custom directives are kind of neat. You've probably seen them before because they're actually part of the GraphQL spec. Here's one that you've probably seen. It's the deprecated directive, where you can, if you have a field that changes name, you can give the user a reason. And that way, when they try to call that field in their query, they'll get a little notification like, hey, the location field has been deprecated. It's now called event location. So we can actually make these ourselves. The deprecated one, for example, gets added here when you're defining your query, and we can do this ourselves. So custom directives are pretty interesting. They're actually part of the GraphQL spec. As I mentioned, they are best used to change behavior at runtime. And because of this, there's a lot of different use cases for them. One really popular use case for them, other than like the deprecation thing, is internationalization, because they can maybe change a string on the fly, do some translation, and it's kind of an intermediary use at the time of the request. So it's pretty neat. And we can also use custom directives to control access all the way down to the field level. So if you only want to show certain fields for certain users, like maybe you have admin users and you don't want other users to see other fields, you can use a custom directive for that. So if we look at the anatomy of a custom directive, it has a few different pieces. First, you have the name of the directive. Here we're creating a directive called has permission. And then we're going to give it an argument called permission of the type string. And then we also need to specify where this gets used. So here, we're going to use this on the field definition. You could also maybe use it on the object or other places. So once we have that, then we actually, this is sort of like the designation of the directive, but we actually need to define the functionality of it. So this is an example using Apollo in JavaScript. Other libraries kind of do similar things. But in Apollo, what you'd do is you'd have this class where you have this, call the class has permission directive, and it extends this base class that is provided for these directives. And inside of that, you have to define this function. You basically override a function called visit field definition that receives the field. And inside of here, you're going to pull off the permission that is used in the argument. So let's say we had a create event permission, and we put this directive on a field and pass that argument in as the permission we want. So we're going to pull that off. And then when we go to resolve this field, we're going to pull off this little function called resolve. And inside of here, this is where we're going to do all the work. So we're going to say, hey, okay, I need to check to see if we've got the current user. If not, we're going to throw an error because we want the user to be logged in order to get to this field, in addition to having the right permissions. So we'll do that check. And then we're going to we're going to use our little has permission function, and we're going to pass in both the user and the permission that we pulled off the arguments. And then we can we can check to see if the user has that permission. If so, then we're going to go ahead and resolve the field. Otherwise, we're going to throw an error. There's kind of a lot going on in this function. So if at first glance it looks confusing, that's because it kind of is confusing. But don't worry, just kind of walk through it and step through it piece by piece. Okay. Let's get through that. Okay, so then once we have the directive defined, we can actually add it to our schema. We can create this object called schema directives and pass it in. And once we've done that, now we're able to actually use it in our schema. So for example, we've got the create event mutation, and it's going to return an event, but we're going to add this has permission directive with the create permissions permission. And so now the only time a user can call that create event mutation is if they have that create permission. So custom directives are really cool. They do have some downsides that you should be aware of. They're really powerful, but the one issue to be aware of is that they couple your logic to your schema. This isn't necessarily a bad thing, but it is something that you want to be aware of. The other thing about custom directives is they can be quite difficult. I mean, if you just saw that class just to get this simple one working, there's a lot that happens here. And what's difficult about this is that it's hard to remember all of the different edge cases that you might come across. When you're tinkering with logic down at this very rudimentary level of the field, you've really got to be careful about thinking through like all of the different times you're going to need to access that field. So be careful, use a lot of testing. This is kind of a whole subject that you can dive into. One great resource on this is a talk that Ryan Chankey gave a couple of years ago called Supercharge Your Schemas with Custom Directives. A nice little dive into this. Also at GraphQL Asia in I guess that was this year, goodness. There were actually several talks about custom directives. So encourage you to go and dive into these things. The Apollo docs actually have an example of authorization with a custom directive. So that's another great resource on this subject. Okay, I've hit you with a lot here. So let's just do a quick review. We talked about how for the user, the GraphQL server is really just sort of an intermediary between the database. It's a layer over the database. And in a simple scenario where we have the server and the front end on the same server, we might be able to get away with just using a cookie and a session and everything's fine. But when we get a little bit more complicated, we start having to deal with third-party APIs, maybe an API gateway, and the problem becomes one of delegated access to things outside of just the first-party server. So we talked about the access token and how the authorization server will send that access token to the front end, which will then pass that along to our GraphQL server. We also talked about how a great format for this is the JSON Web Token. And the JSON Web Token, the JWT, is a great format for this because it can both contain useful information like claims, and it can also be signed and verified, so we know for sure where it came from. We talked about how the best place to pull off a token and verify it and return the payload is in the context. And then we can check in our resolvers if we have our current user to see if we're logged in, and then work on finding our permissions and calling the database. We also looked at several libraries that can help with authorization in GraphQL, like GraphQL Resolvers, where you can use this combine resolvers function and pass in a few different methods there. We talked about GraphQL Modules, which is another great library by the community, where instead you can kind of add this map to say, okay, when you come across this mutation, use these other resolvers on top of it. And we also looked at GraphQL Middleware, where you can define these kind of key value pairs of middleware that you want to run before a mutation or query is resolved. Lastly, we did a quick look at custom directives. So we looked at creating this has permission directive that takes in a permission, and it's on the field level. And then we looked at being able to add that to our create event mutation and control who's able to actually run this mutation. So I just want to leave you with, I don't know how many of you have listened to Nader Dabit's GraphQL Patterns podcast. They've had a couple of episodes on auth that are really helpful. And there were just a couple of takeaways that I wanted to leave you with. So one thing that I think is really important to remember, if you kind of step back and look at the big picture here, is that really good schema design is really the most important goal of what we're doing here. As with most backend things, kind of garbage in, garbage out. So design the schema to require only as much auth as you need. Think through whether auth is needed at the object level or the field level. I mentioned how with custom directives, if you're at the field level, you're going to have a hard time remembering all the different little edge cases that you need access to that field. So think that through. And lastly, don't design mutations that can change arbitrary objects. Instead, do some experimenting. Think through whether you want to send a null value instead of throwing an error, and kind of consider the trade-offs with that. Most things with GraphQL are a little bit nuanced and require looking through your use cases, and auth is really no exception to that. So thank you so much for watching this. I have all of the slides as well as a whole host of resources and sample code at samj.im/GraphQL auth. And with that, thank you and have a wonderful rest of the conference.